Hello, my dear students. Welcome back to the lecture. So, in this lecture, we will see how to prepare the slab BBS for a one-way slab, and then we'll also see for the two-way slab. Now, I'm hoping that at least a basic understanding you have how a one-way slab looks and how a two-way slab looks. So, I'd already explained you for the cut reinforcement. So, when it comes to the crank bar, this is called as cranking of bar. Like you get a bar, you bend it like this, you take it straight in this way. Okay. Then another bar will come from here. You crank it and you take it like this. So this is called as alternate cranking of a bar. So in this lecture, I'll explain you how the cutting length of this complete one-way slab has to be done. So for my calculation, what I've done is I've taken the length of my slab. Okay. I've taken the length of my slab, that is this length. Inner to inner, the shorter span, it is around 3 meter, I guess. And this length I've taken around 5 meter. Just understand that. The rest all things I'll explain you from the cross-section point of view. So the length of my slab is 3000. Let me check it. Yeah, 3000. And so the breadth of my slab and the length of my slab is 5000. So practically, if you ask me, this is how it looks. This inner to inner is 3000 and this inner to this inner is 5000. Understood? Right. Now we'll start with this. Okay. So it's very simple. I'm expecting that most of the things you know here, it will just, I'll just explain you how it has to be done practically. Okay, fine. Now let us consider that this is a slab, what I have. So the black color, whatever you can see, it is a beam, what I have. And the one which is yellow in color, it is a slab for me. Now you require a cross section for that. So again, if I cut the slab and see it from here, this is how it looks. Okay. So the black one is, this is first beam. Let us consider this is that beam. And this is equal to this beam, right? And this is the reinforcement what I have put. The blue color, what you can see, it is a bottom reinforcement, and then comes your distribution steel here, and then comes your top extra bar and all those things, which I'm going to explain you in the future, in the further lectures. Okay. Understand one thing. The width of your beam on both the side is 230. This is also 230 and this is also 230. And this span, whatever I have, it is a 3000, right? So this much understanding I want you people to have it. Fine. Now, practically how you put a bar. So you start a bar from here. You take it like this. You give a crank here. The meaning of crank is bending. When you bend something, we call it as a crank. So you give a crank or you do a bend here. You take it to the top here, right? So this is first bar what you put. Once you put this bar, next bar will start from here. You will take it here. You give a crank here. You take it here. So in this way, it is going to be a alternate cranking of a bar. So one will come from here. It will get a bend here. It will go here. Next will come from here. It will take a bend. It will go in this way. So in this way, that particular scenario, that particular case is going to follow. One straight and crank, straight and crank. Got it? So this is how your bars are put. So always the bars are put in the shorter span first, followed by your longer span. So this is my shorter span, which is 5 meter. Sorry, which is 3 meter. And this is 5 meter. So 3 meter is less compared to the 5 meter. So the first bar will be placed parallel to the shorter span. So this is parallel to this length, isn't it? So that is why these bars are put. So once you put this bar, next we put a distribution steel. Now I'm using a term called as distribution steel. Since it's a one-way slab, we give this bar in the longer direction and it will serve as your distribution bar, which will take care of your temperature, thermal cracks and shrinkage point of view. Okay. Yeah. So this is 3000 from inner to inner and this is 5000. First, I want to find the cutting length of this bar. What is that? First, I want to find the cutting length of this bar. The bar which has gone like this, isn't it? I want to find the cutting length of this bar. Got it? So how do I find that? That I'm going to teach you now. Yeah. So the cutting length of the main bar. So your bar is starting from here, isn't it? So the width of your beam is 230. So 230 I'll write first. Plus this straight portion I want. This straight portion I want to find. Which one? This portion. From here to here I want to find it. But I don't have a straight value for that. But I have a way to find it. The way to find is, I know from here to here it is 3000. Okay. And this particular length what I have, it is L by 4. Now from where did I get L by 4? It is given here. Can you see it here? This crank portion, if you see here, this bar, which is getting crank like this. From here, this crank portion, whatever you have, so it is called as L by 4. So what is L? L is your this span, 3000. So 3000 divided by 4 if you do, you get this particular crank portion. Okay. Okay. Yeah. So what we will do, no? Anyhow. Okay. So this is 230. Forget about this. This is not required. Okay. We'll go with a straight length. So this is 230 plus from here to here. This length, what we have is 3000. Okay. And then this width is again 230, right? So I got outer to outer. From here, I'll deduct one cover. From here, I'll deduct one cover. So one cover, you can see a space here. This is a cover what we have left. So it's a beam. So beam, it is 25 mm. From here also, it is 25 mm. So if I do this much, and then last one portion is left out, which is that this is bend. This crank length, I don't know how much it is. So how do you find it? For this, there is one formula, and the formula is 0.42 into h. So you just have to remember 0.42 into h. So in the upcoming lectures, I'll be explaining you from where did this 0.42 h came into play. But right now, just understand, for all the crank, whatever you have, this will be 0.42 into h. And what is h? That I'm going to explain you now. Okay. So whatever I explained you, I put it down here. This is 230. So this is 230 for me. Plus this is 3000 inner to inner. So 3000 plus again this is 230, right? Now from here I have deducted one cover minus 25, minus 25, minus 25 from here, minus 25. Plus this crank length is 0.42 into h. So I written 0.42 into h. H I got 100, but I'll explain you from where did I get 100. Right now understand this is 0.42 into h minus bend deduction. See again, bend deduction, if you want, you can do it. Else it's not required. But let us do the bend deduction. So how many bend will come? Tell me. So this is one bend. This is one bend what I have. Let me, give me a minute. Yeah. This is one bend, right? This is one bend what you have. It's a 45-degree bend here. Then you get another 45-degree bend here. So there are two 45-degree bend. So one 45-degree bend is how much? 1D deduction. So we have two. So 2 into 1 into D. So that is why I've written 2 into, that is two bends are there. One 45-degree bend is 1D. So 1 into D. You try to do these calculations. Okay, you should get 3432 mm, or which is 3.42 meter. Understood? You understood the concept? Fine. Now we'll come to the most interesting part. That is about the this part, which is that 0.42 into h. From how did we get that h value? Okay. So for that, yeah, we'll start with this. Let us consider this is a slab what I have. And the depth of my slab is, or the thickness of my slab is 150 mm. So this is 150 mm. Understood? Now, this is how you put a bar. That is, you are given a crank here. I mean, you are taken it to the top. You are given a crank and bar has been brought like this. You do it either way. Now, you may even do from this way also. Like, you'll take a bar from here. Your bar will go like this. Okay. You give a crank here. You take it like this. One and the same. You can follow any method. I mean, any crank. Either the top here or the top here. Okay. The calculation remains the same. I'll go with this. I've taken a bar. I've given a crank here. I've taken it to the top. Now, this h value, what I want. So this h value, I'll take from center to center. That is center of this rebar, center of this rebar to the center of this rebar. You're getting my point, right? So let us say the diameter of the bar is 10 diameter. This is 10 diameter bar. It's a 10 diameter bar. So I'll show you in this way, center to center in the sense, because few students don't understand that. So I'll draw a rebar here for your understanding. If this is my rebar, okay, it will come like this, isn't it? Hmm. Okay, fine. So when I say center to center, from this center to this center, I'm taking this center. This is my H. This is my how much? This is my H. Understood, no? Same thing I've shown it here. From this center to this center, this height, whatever I'm gonna do, that will be my H. Okay, got it. Now, how do you find that H? For that, there's a small calculation which you need to understand. So the calculation is H equal to, what is the thickness of your slab? The thickness of your slab is 150. And since it is a slab, we have to do the deduction for the cover. So one cover will go from here. This is one cover which you are going to do the deduction for this cover, okay, which is 20 mm. And also you'll do the reduction of the cover from here. This is also 20 mm. Got it? Finish. Now we are taking center to center. So if this bar diameter is 10 mm, so from, if this is 10, what is the center of 10? That means center in sense 10 divided by 2, 5 mm. So from the top, I'll deduct 5 mm. And from bottom also, I'll deduct 5 mm. So whatever H I'm gonna get, no. So if you do that calculation, you'll get the H. So I've written 150 is the thickness of the slab, minus 20 cover from the top, minus 20 cover from the bottom, and it's given 10 diameter bar. So minus 5 from the top, minus 5 from the bottom. So it will be 100 mm. So that is why we got 0.42 into H. I took 100 mm. This is one case. There are few people, those who practice this method. So what is this method? Check it out. I'll show you what is this method. Okay. What happened to this? Yeah. So this is another method. So here, H what value I'll do is the second one what you can see. Okay. Just concentrate here. Again, in this case, I'll go with this one. Here my H is this one. From where? That is from the top. From this top I'll take to the top of this. This will be my H. Your answer will remain the same. Either you can go with center to center or you can go with this one. That is the top of this bar to the top of this bar. So again, how you'll do the calculation? It's very simple. So H equal to, H equal to 150. Your thickness of the slab is 150. From here, I'll deduct one cover. So this is one cover which I'm going to deduct, which is 20 mm. So I'll reach to the top only. Okay. And from here, I'll deduct another cover. So this is again minus 20. Okay. So I'll reach to the bottom. By H value is from where? From the top. From this top to this top. Right. So what I'll do? Minus, I'll do 10 mm. Which 10 mm? This bottom 10 mm I'm going to remove. You're getting my point. Bottom 10 mm. Because top you're taking from the top of the steel. Top of this steel you're taking. And here you're going to the top of the bar. That means this rebar you don't have to deduct. This top 10 diameter you don't have to deduct because it is from the top of that rebar. Whereas here it is from the top of this rebar. So you have to deduct the 10 mm. If you don't understand from there, I'll draw it like this. See, this is a rebar what we have. Okay, I'll do like this. And then this is a bar which goes like this. It will come like this. It will be like this, right? Yeah. Okay. Yeah. So now this time your H value is from here. Your H value is from here. That is from this top to, wait, from this top to this top. This is your H value now. This is your H value. Got it? Now you understood? See. So again, it will be how much? 150 minus top cover you remove 20 mm minus bottom cover you remove 20 mm minus this bottom diameter what you have, no? This diameter I'll deduct. Top you don't have to deduct because we are taking from the top of that rebar to the top of the bottom rebar. So that is why I'm deducting minus 10. So both the way you do, your answer is 100 mm only. So few people follow this center to center. Few people follow this particular case. You do anything or even you can follow this particular case, which is that, yeah, from the bottom of this bar to the bottom of this bar. Got it? Answer remains the same. That's it. Understood, right? Yeah. So that is why in my calculation, I have taken this particular thing. Yeah, now you got the idea, like how all these things are done. So you got it, right? So 0.42 into H is 100 mm. So your slab thickness is 150 and so on. Finish. Now we'll find the number of bar. Now we have found the cutting length. But how many such bars are put? 1, 2, 3, 4, 5, 6. How many such bars are put? So whenever you want to find the bar in a shorter span, the length I should take is a longer span. This length I'll take, that is 5,000. So 5,000 divided by 200. So here, let us consider I'm using a 10 diameter bar at 200 center to center spacing. This main rebar, what I put, no, it's a 10 diameter bar at 200 center to center spacing. So number of main bar will be 5,000 divided by spacing is 200. So since it's a spacing and we are doing center to center, we'll add +1 to that. So try to do this calculation. 5,000 divided by 200. It is 25. 25 plus 1 is 26. So you get 26 number of bar. So in this way, we'll be putting 1, 2, 3, 4, 5, 6, 7, 8, 9. 26 number of bar will be put. Finish. Now, this is your distribution still. The which is what you call the purple color is called is your distribution still. You have to find the cutting length of this. So always cutting length whenever you want to find, first thing that should come in your mind is outer to outer. So again, if I want to find outer to outer, this is 230. This length is 5000 plus this is 230. From here, I'll deduct one cover minus 25. From here, I'll deduct one cover minus 25. Your cutting length is done. See, 230 plus 5000 plus 230 minus 25, one cover from here, minus 25, one cover from here. It is 5.41 meter. Got it? Fine. Now, how do you find the number of bar? Now, for the number of bar, that is a distribution bar, how do you find? So again, it's the same thing. If you want to find the distribution bar for this, yeah, we'll do from here only. Yeah. Now, next is we'll find the number of bar. That is the number of distribution bar we'll find. Okay. So this is called as, how do you find? Your bar is being put in this direction. So you have to take this length, that is 3000. So 3000, when the distribution bar is spaced at 200 center to center spacing. So 3000 divided by 200 you do. So 3000 divided by 200, and yeah, 3000 divided by 200, it is 15 plus 1 is 16. So I've written 16 number of bar I have put. This much is understood. Main bar cutting length we understood. We understood the number of bar. Distribution steel cutting length we understood. We understood the number of bar. Now what is left out? The next part what is left out is called as crank distributor. Now what is this crank distributor? I'll explain you through a practical example. See here. Can you see right now this distribution steel we found? Okay, this distribution still we have found, all this bar we have found. Okay, cutting length you understood, number of bar you understood, but again there is one bar which is going at the top of the crank. So this is my crank portion. You can see the top steel, one, then again two, three on this side, another you can see one at the top. Can you see those bar? So it is called as crank distributor. So you need to find the cutting length of that. So you may ask, sir, just now we found distribution steel. Is it not included? No. This distribution steel, what we found, no, it is actually going in the bottom. Like in the bottom, those things we calculated. All the bottom which has gone, that we calculated. But right now, the crank distributor is above the crank. This is crank bar. Above this, your distribution bar will be put up, right? So in the same way, I'll show you one practical image here. Yeah, this is very clear. Can you see this guy? This is a crank we have. Over that, you can see one bar. This is one bar, second rebar, third rebar, fourth rebar, fifth. So the cutting length will be same, but number of bar will change. In the same way, can you see here? These people have just put one crank distributor. Rest bar, they have kept it ready here. Later, they are going to do that. So in this way, the bar will be put. This is called as crank distributor. Understood? This is what we are supposed to find. How do you find? It's very simple. You know this crack length? You know this crank length, isn't it? This from here to here, this is crank length, which is L by 4. This crank length, you know, from here to here, it is L by 4. So wherever the crank has happened, only then, only that place you're putting your crank distributor. So crank length divided by the spacing of your crank distributor will give you number of bar. Very simple. Whatever crank length you have, that you divide by the spacing of the crank distributor, you get the number of bar. The same calculation we are going to do now. So two things I've shown you practically. In the same way, I can show you, yeah. Yeah, I think most of the things it's very similar to that. If you want, I can show you one more here also. See here. Here also you have the crank distributor. See, this is a crank bar, isn't it? So over that you can see one. Over that you can see second bar, third bar. So hardly 4 to 5 number of bar will come usually. Okay. Sometime it may be 5 or sometime it may be 6, but not more than that. You can see. It depends on the condition of the slab. Okay. See, this is crank distributor. So if I want to find the number of bar, what I'll do? Simple. I should be knowing this crank length. This crank length I should be knowing, which is L by 4, right? So L by 4, in our case, L we had 3000. 3000 divided by 4, you do it. 3000 divided by 4, it is 750. So this length is 750. Okay. So, and the spacing between the bar is, let us say 200. So 750, and the spacing this, between these bars. Spacing between these bars, spacing this between this bar, spacing is actually, let us say, it is 200. Okay. 200. So what you do? 750 divided by 200, you do 3.75. You add plus 1 to that, 4.75. 5 number of bar will come. So practically what will happen? 1, 2, 3, 4, 5 number of bar has come here practically. Getting my point? Same thing I'll teach you. I mean, I already explained you. Same thing I've written it here. So you can see the same thing which is now it's written at top crank distributor. So I've written L by 4. So what is L by 4? That is L is your, I'm putting the bar in this way, okay? This direction I'm putting the crank distributor. This direction. For this direction, I have to take this length, 3000. So 3000 divided by 4 is 750, I told you. So 750 and the spacing is 200. So you do that, you get 3.75. 3.75, you add 1 to that, 4.75. We can say it as 5 number. So 5 bar is required. But this crank distributor will put on both the side. That is, on this side also your crank distribution will come. Here also your crank distribution will come. And this side also your crank distribution will come. So I'll calculate for one side and I'll multiply it by 2. So both the side I'll get. See here, both side it will be 5 on each bar, each side. So 5 into 2 is 10 number of bar. Understood? So this is about the crank distributor. Got it? Yeah. After that, next is top extra bar. After this, there is one more thing which will come, which is called as top extra bar. Now, what is this top extra bar? So practically, I'll show you what is this top extra bar. Yeah, crank you understood. Now top extra bar, we'll see that. Okay. Crank distributor. See, this is your crank distributor. Now here you can see it clearly, like 1, 2, 3, 4, and this is crank distributor. Okay. Yeah. Now we'll see the this thing top extra bar. Yeah. So for top extra, yeah, this image is good. Yeah. So now concentrate on this image. See, next you put a top extra bar. Always remember, top extra will come in between the two crank. Simple. Where the top extra will come? Wherever you have two crank bar, in between that your top extra will come. For example, see, this is one crank what I have. This is a crank bar what I have. This is a crank bar what I have. This is one crank. My second crank will come here, right? So in between these two crank, we have a space. So that space is little more. So there your negative bending moment will be dominant. So that is why in order to take care of that, we provide one top extra steel. So this is your top extra steel. Got it? So this is your top extra steel. Similarly, see here, this is one crank. This is second crank. Wait, this is one crank. This is second crank. In between that, you are providing a top extra. You have one crank here, your second crank here. In between that, you are providing a top extra. Same thing, you can see it here. Same picture, I've shown it here. See, this is one crank. This is second crank. In between that, you have provided a top extra bar. Another crank, you have provided a top extra bar. Got it, no? So wherever there is a two crank, in between that, you have to provide a top extra. Finish? This much you understood? Great. Now we'll find the number of bar of the top extra and also we'll find the cutting length of that. Okay. Yeah. For that, I'll take you here. Yeah. Yeah. So first we'll find the cutting length of the top extra. Your top extra will put up like this. Your top extra will come like this. Okay. Your top extra will come like this. Yeah. This will be a top extra. In between the two crank, here it will come. Over this bar only your top extra will come. This is your top extra. 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 So this is crank, this is crank. In between that, on over this bar only your top extra will come. Similarly, here top extra will come because crank 1, crank 2, top extra, top extra, top extra, top extra. Got it, no? This much you understood? Top extra. First, explain me how you will find the cutting length. Cutting length is very simple. You should know this length. From here to here, it is 230 mm. And from here to here, it is L by 4. So, this is 230 is the width of the beam. And this is L by 4. So it is 3000 divided by 4 is 750. So 230 plus 750 minus 1 cover if you do, you'll get the length of this. Same thing I've written. 230 is the width of your beam. So 230. So this is crank length, which is L by 4 we got. So 750 minus 1 cover if you do, you'll get 955. So this cutting length what we have is 955 mm, which is 0.955 meter. Got it? So what I have found it for one, all other it is same. Now we'll find the number of bar. To find the number of bar, how you will do that? So number of top extra will be, see, the spacing between these two bar. The spacing between these two bar will be double the spacing of your main bar. Your main bar, the spacing was 200, right? So the spacing between these two crank will be 400. Got it? The spacing between these two crank will be 400. Why? Because this spacing we found that initial calculation we took, center to center spacing is 200, center to center spacing is 200. If this is 200 and 200, then obviously the spacing between these two will be 200 plus 200 is 400, right? So that is that the spacing between the two crank is 400. But again, if you observe it carefully, you have one crank from here to here. This is one crank. Next crank is here. So the spacing between these two will be actually how much? 200, right? The spacing between this crank and this crank you check. If I go in this way, it is 200 only. So either you can take 400 and you multiply it by 2. Else you take directly 200 and don't multiply it by 2. You're getting my point? So if you want to find only one side, then you have to take spacing as 400, multiply it by 2. You get on this side also. If you don't want to do that, then what you do, the spacing is 200 only, because this crank, this top extra and this top extra, this spacing is 100 only. This top extra and this top extra, the spacing is the spacing is 200 only. So directly this length divided by 200, if you get, you'll get the total number of top extra, including on the left side, including on the right side. That can be done. Okay, you're getting my point? Chalo. Same thing I've done. So number of top extra, what I've done is I've taken 5,000, because this bar is being put in this direction. So my length will be this, isn't it? So 5,000, I'll do two calculation. So 5,000, you divide it by spacing is 400 and plus 1 you do. Tell me what is the answer you're getting. So 5,000 divided by 400, it is 12.5 plus 1 is 13.5. Let us say 13 number only, 13. So 13 number I got on one side. This 13 number I got on one side, this side. So this side also, if I want 13 into 2, how much it will be? 26 number of bar. So if I do this 13 number, so both side will be 13 into 2, which will be 26 numbers. Got it? Other way of doing is that directly take the length. The length is how much? 5,000. You divide by 200, because this and this is 200 and plus 1. Then also you'll get 26 number of bar. So either you can follow this method, directly the span divided by the spacing between two top extra. I mean alternate top extra, or the two top extra if you take, you have to take 400 plus 1 and multiply it by 2. If you do this method, then you don't have to multiply by 2 again. Okay. Got my point? So this is how you practically do a one-way slab BBS. So I hope you have enjoyed my lecture up to here. You got an idea. You just have to watch my lecture once again if you're getting confused, because slab, it is not that easy for you to understand like you understand footing, column, beam and all. So slab will take little time for you to understand, because there are different bar. Okay, one is bottom, one is a shorter span main bar. Then we had a distribution steel. Then we had a crank distributor. Then we had a top extra. In case of two-way slab, another two extra bar will come, right? Because top extra only two side we are done. On this side also your top extra will come. And also your crank distributor only shorter span we are done. In two-way slab, even this side also your crank distributor will come. So another two extra bar will add up in case of two-way slab. So when I come to the two-way slab in the next lecture, I'll explain you all those things. So if you still have confusion, go through my lecture once again and you'll be able to understand that. And moreover, I've shown you all the practical images only, like how it looks and all. So just take a screenshot of this if you require, so that you don't have confusion. Now we found this top extra length, okay? From here to here, this length we had found. We'll see you back in the next lecture. Thank you.